Hi, this is Callan Bentley. Welcome back for another Smart Figure. After watching this video, you should be able to describe the 6 situations in which plate tectonics influences volcanism. This is a close-up from the middle of the big spread from your textbook that shows these different situations. Volcanoes can be produced in 6 different situations. First is a convergent plate boundary where oceanic crust is being subducted underneath continental crust. A second situation is where oceanic crust is being subducted underneath other oceanic crust. Volcanoes can also be produced at divergent plate boundaries, such as where 2 plates made of oceanic lithosphere are separating from one another, or a spot where a continental lithosphere is rifting apart. Furthermore, we can get volcanoes where hot spots rise through continental crust, or where hot spots rise through oceanic crust. Let's take a look at each in turn. The situation with a convergent plate boundary where oceanic lithosphere meets continental lithosphere is that the subduction of the oceanic lithosphere triggers melting in the overlying mantle, and that produces magma. The magma rises through the crust and ends up erupting at the surface as a continental volcanic arc. The situation with oceanic lithosphere meeting other oceanic lithosphere is very similar. Subduction occurs, mantle melting is triggered, and magma rises up through the overlying lithosphere to erupt at the surface as lava. However, here, what's produced is a volcanic island arc. These 2 types of volcanism are what characterize the ring of fire, the chain of volcanoes that wraps around the Pacific Ocean. We can also get a situation where we have divergence, and that produces volcanism. Basically, what happens here is that the crust and the lithosphere are thinned, and that causes decompression melting of the underlying mantle. So we tend to get mafic volcanism here, basically iron and magnesium-rich magmas that are derived from the partial melting of the mantle. So this is a situation like we see in Nevada today or in the Great Rift Valley of East Africa. We can also have divergence at oceanic ridges. So here's an example, for instance, like the Mid-Atlantic Ridge or the East Pacific Rise, where 2 plates are moving apart from one another, and that basically, again, triggers decompression melting of the underlying mantle. Magma is produced, and it rises up through those cracks to form new oceanic lithosphere. Finally, we have 2 situations where we can get hotspot volcanism, so a mantle plume is rising up through the mantle and interacting with the base of the lithosphere, and it produces melting that ends up causing volcanism on the surface. So we can have this happen in a continental setting, such as with the Deccan Traps in India or the Columbia flood basalts in the Pacific Northwest. Or we can end up having this situation arise underneath oceanic lithosphere, as is the case with the U.S. state of Hawaii. Now take a look at the North American plate here. You can see that one North American plate boundary is over here in the middle of the Atlantic Ocean, and then we've got another plate boundary, which is a transform boundary down in the Caribbean. There's a subduction zone. Then we've got another transform boundary here, which is the San Andreas Fault, another subduction zone, another transform boundary, and then another subduction zone. We also have hotspot volcanism occurring at Yellowstone and at Hawaii. In terms of where you live, what's the nearest source of volcanism, and which of these 6 types does it fit into? Well, the answers, of course, will vary, but it's a good thing to be aware of. Thanks very much for your attention. This has been another Smart Figure.